Hello dear students, in this lecture we are going to learn about HCF and LCM, two of the most crucial topics in mathematics. Now before we start, I would like to clear there are two ways of studying mathematics. The first one in which you just solve the answer, you just solve the question, you get the answer and you're happy, so that you think that you have learned mathematics. But have you really understood it? No, because only getting the answer will not lead to understanding of the concept. Now why understanding of mathematics is important? Because you might know that while attempting a question, initially you might think that you are able to do it, but you get stuck. And when you get stuck, it means you couldn't have understood the concept thoroughly, you just have gone through the questions and you expect the answers to come out in the examination hall. But that does not happen. So the best way to avoid such mistakes and to improve your mathematics is to get hold on the concepts and then practice thoroughly about that. So in today's video, we are going to start with LCM. LCM is lowest common multiple. Now what does this thing means? This thing means that it is the smallest number that is divisible by both the given numbers to me. Let's say for an example, you are asked to find the LCM of numbers 3 and 4. Now first of all, we'll list down all the numbers that we can divide with 3 and 4 or which are divisible by 3 and 4. So if I write 12, 24, 36, 48, 60, 72 and so on. So I would see that all these numbers are divisible by 3 and 4. Right? But when we are finding the LCM, we would be looking for the smallest number which is divisible by both of them. So hence we can say that the LCM of 3 and 4, LCM of 3 and 4 is 12. Right? So we'll see how we are going to find out the LCM. In LCM, the first method is prime factorization method. In this method, we will list down the prime factors of the given numbers and we'll find out the LCM. Let's see how. Let's take an example. I think if you have noted it, you can take a screenshot or you can note it down in meanwhile. LCM, though it might look very easy, but you will very amazed to see that most of the students will make mistakes or small errors even in the examination and test, even in this simple topic. So to eliminate that thing, let's give you an example. The first example is we are taking numbers as 24 and 36. Right? The first step is finding the prime factorization of these two numbers. So 2, 12, 6, 2, 3, 3 and 1. 2, this will be 18, 2, this will be 9, 3, this will be 3 and 3, this will be 1. So this is how we do prime factorization of the numbers. Then the next step is write down the numbers in terms of their exponents. Exponents or powers, you know, if 2 is multiplied by itself, it is 2 raised by 2. If it is multiplied by itself again, so it is 2 raised by 3. You have studied it in the previous classes. So 2 raised by 3 and here it is 2 square into 3 square. Now the first step was getting the prime factorization done. The second step is writing down the prime factors in the exponent forms. Then since we are taking the LCM, we'll take the highest powers among the common factors. So we have 2 and 3, both the numbers in both the factorization, but we have to choose the highest power among them. Now with 2 raised by 3 and 2 raised by cube, the highest power is 2 raised by 3. And with 3 and 3 square, the highest power is 3 square. So the number becomes, this is 8, this is 9 and the answer is 72. So I can write that the LCM of 24 and 36 will be 72. Now as per the definition, as we said, that the LCM should be divisible by both the numbers. So let's see whether our LCM is divisible by both the numbers or not. Now this is divisible by 3 and this is divisible by 2. So yes, the LCM is correct. So in this case we can say the first case is find out the prime factorization, list down in the form of exponents, then choose the highest power among them and you will get the answer. And then you can verify it in the examination. If your answer is divisible by both the numbers, then it is true. Right. Let's take another example. Meanwhile, you can take a screenshot if you want to. I hope you have recorded it. So now, let's take few more examples to understand it better. Examples are very crucial. Most of the students run after examples that they jump on directly to the question exercise. But examples are important so that you get the confidence of solving those questions. Right? Let's say 21 and 30. Examiner is asked to find out the LCM between 21 and 30. 21, 30. Again prime factorization. This is 3, this is 7, this is 1, this is 2. This shall be 15, 3, 5, 5 and 1. So now the factors will be 3 and 7 and the factors is 2, 3, 5. Now this particular example is quite different from the previous one. In the previous one you had two common factors and you had different variables. Now all the exponents are same and numbers are not even common. So what we are supposed to do in this case? In turn, when we are taking the LCM, you will choose all the numbers which are present over here, right? So we'll see 2, 3, 5 and 7. Why we have not chosen this 3? Because it is already there. If it would have been 3 square, we would have written 3 square over here. Or if it would have been 3 4, we would have written 3 4 over here. So that is the highest power. Now since the highest power of any of the numbers over here is 1, so hence all the numbers are in power of 1. So now this should be 210. So my LCM for 21 and 30 becomes 210. Let's see if 210 is divisible by 21. Yes, it is divisible by 21. And if 210 is divisible by 30. Yes, it is also divisible by this. And since these two are also factors, this is a prime number and this is just a number, so it is also true that the LCM is this and this will be the smallest quantity, right? Now let's take another example, because there are some properties that will be described on the basis of examples. Let's see if we can find it out. Meanwhile, you can practice the questions from your books and other variable data. So let's say if I am taking LCM of 16 and 48. So 16, 48. Now many of you will say that 48 is a LCM. So this is a kind of a shortcut also. You can verify your answer that if one number is a factor of the other, or if it completely divides the other number, the largest among them will be the LCM. Don't worry, you will list down in the properties. So this is 2, 8, this is 2, 4, this is 2, 2, and this is 2, 1. This is 2, this is 12, sorry, this will be 24, 2, 12, 2, 6, 2, 3, and 3, 1. So now this is 2 raised to the power 4 and this is 2 raised to the power 4 into 3. So the LCM should be 2 raised to the power 4 into 3 and hence it is again 48. Now we can also say that 16, 48, 48 by 48, this is 1 and this is 3. Again they are prime numbers, so you won't get any number that is smaller than this, which is a LCM of the given numbers, right? So with these three examples, we have made sure that first of all, after the prime factorization is done, either you will choose the highest power among them, or whatever the highest, the unknown values over there is, has to be also be taken care of. Now, on the basis of the examples, we will list down the properties of LCM. This is very important. Now, properties of LCM, what does it mean? That if A and B are two given numbers, so LCM is always greater than or equal to A or B. Right? For example, if we have taken the numbers as 4 and 5, the LCM will be 20, which is greater than 5 and greater than 4. So whatever the number is, the LCM are supposed to be either equal or greater than this. LCM in any way can never be less than the given numbers, that is A and B, right? Then it can also be equal. The last case that we did, 16 and 48. So 48 was the LCM. So we can say this is the case for when the LCM was equal to one of the given numbers. One of the given numbers. Right. So whenever you have to choose which number is this. So let's say if A divides B completely. So this would say that A is smaller than B. Only then A can divide B completely. So then B will be my LCM. So even in this case you can say that A divides B completely. Hence B will be the LCM. Right. So with this, I hope you have understood the LCM. We'll take on HCF in the later section because it is solved by two ways. One is the prime factorization and other is the Euclid division algorithm. Hope you like it. You can keep like the videos so that we can post some more of the contents over there. Thank you.